This is Algebra 1, Lesson 34, Greatest Common Factor, or GCF as it's often called. We're going to do examples 34.1 through 34.3. We're going to start with a little bit of a review of factoring. So we're going to do a factor tree for this, or you could do repeated division. I notice that it ends in 0, so I'm going to know that that's divisible by 10, and 10 times 21 would give me 210. Neither of those are prime, so I'm going to break it down until I get to all prime factors. 21's 3 times 7, and we end up with all of the prime factors. So I could list those and say that 210 is the same as 2 times 3 times 5 times 7. And you could multiply those out, and you would find out that you get 210. Now, this lesson is going to talk about those being numerical factors, just numbers that are factors of this product, 210. We're also going to start talking about literal factors, and those are just factors when you have a variable, the variable part of the factor. Now, this number, 210, does not have any variables, but we could change it. Let's change it up a little bit, and let's say that it had x, y squared, z cubed on it. Then the prime factors, we would change it, or the factors, I should say. I would have to list the factors of those variables, which would be my literal factors. So I would list x times y squared is y times y, and z cubed is z times z times z. So now I have the numerical factors listed, and I have some literal factors. They're going to talk about algebraic factors, and that would just be all of these, whether it's your numerical factors or your literal factors, it's all of them. And that's what we're really going to be dealing with, is algebraic factors. They're going to say factor, or find the greatest common factor, and we abbreviated it here as GCF. Now, I have a definition for GCF. The GCF, or the greatest common factor of two or more terms, is the product of all the prime algebraic factors common to every term, each to the highest power that it occurs in all of the terms. Now, we're going to do another problem. We're going to look at this, and we're going to refer back to that definition because that's a mouthful, right? There's a lot there. So let's look at this example. We have 3 terms. You see these addition signs. So here's a term, and here's a term. And let's say we wanted to find the greatest common factor of all of those terms, okay? So we're going to look at each term, and we're going to look at the factors. Now, this 6, I can, since the numbers are small, I can think of that as just a 2 times 3, and then this 3 is just 3, and this 3 is just 3. 3 is prime. Now, if I have a 2 times 3 here, and then a 3 and a 3, what do they all have in common? Well, they have in common just a 3, right? And the definition tells me it is going to be the product of all the prime algebraic factors common to every term. Well, there's definitely a 3 in every single term. And we can also see that we have some common variables. So we know we see an x in every term. Well, how do we know what the power is, what the exponent is of x? Well, this term has an x squared. This one just has an x, and this is an x cubed. And our definition tells us we want each to the highest power that it occurs in all the terms. Okay, so it's not just the highest power. We wouldn't use the cubed because you don't have an x cubed in every term. What's the highest power that you have in all the terms? Well, this one has x to a power of 2, this one has it to a 1, and this one has it to a 3. So what do they have in common? Just to the first. That's the highest power that they have present in all the terms. So now let's look at another variable. Let's look at the y's. Here we have a y squared, we have a y cubed, and we have a y squared. What's the highest power of the y's that we have in all of the terms in common? Well, that would be y squared because they all have a y squared. And you could list it out like this if that would help you. What do they have in common? This is what they have in common. They all have at least a y squared, okay? Next, we're going to look at another variable. Let's see, what about m? We have an m squared, we have an m squared, and there's no m down here. So we can't list m or m squared in the greatest common factor because it's not present there. So our greatest common factor of these is going to be 3xy squared. That's the greatest common factor of all of the three terms. And that's what we're going to be doing in this lesson. So let's look at some examples. Example 34:1, find the GCF of, and it gives us this algebraic expression that has two terms. Now let's take the numbers first. Just like in elementary school when you were doing greatest common factor of the two numbers, you still think of it the same way. You've got 8 and 12. What's the largest factor that they both have in common? Well, I would say 4 is your largest factor that you're going to have in common here. And if you weren't sure, you could do the prime factorization of each. 2 times 2 times 2 is 8. And 12, if you did a factor tree, you would get 2 times 2 times 3. Okay, and you know how to do that, so you could do that. What do they both have in common? They both have a 2. They both have a 2 times 2, and that's it. So that means the 2 times 2 is your greatest common factor, so it's 4. So we know our GCF is going to have a 4 in it. Next, we're going to start looking at the literal factors. We're going to look at the variables. We have a z to the 4th and a z cubed. So the highest power that they have in common would be z cubed. All right, next we're going to look at m squared. We have an m squared there and an m to the 4th. The highest power in common is m squared. Next, we're going to look at p. The highest power that we have is this 1. So p, and we don't have to write to the first. So your GCF is 4z cubed m squared p. Let's look at the next example, 34:2. Find the GCF of, and then we have this expression. What is your greatest common factor of your numbers? Well, this one's 2 times 2, and this one's 2 times 2 times 2. So the greatest common factor is 4 for this. The numbers, the numeric part. Now we're going to look at our variables. We have an x squared and an x. The highest power that they have in common is just x. We're going to look at our variables. We've got, for y, we've got y cubed and y squared, so the highest would be y squared. And then we're going to look at z. We have a z here and we have a z cubed. The highest is a z to the 1st or just z. So the GCF for this one is 4xy squared z. Let's look at the last example. The GCF of this large expression. We have 3 terms, 1, 2, 3. In those 3 terms, let's start with the number. We've got a 16, a 4, and a 2. The largest factor that's going to go into all of them would be 4. And you could factor those out and find that. Now we're going to look at our variables. That's the new part of this lesson. We're going to look at x's. And it looks like they have an x squared in common. And then we'll look at our y's. We have a y squared, and a y squared. Just that one y in common. Now we're going to look at our p's. P to the 3rd, P to the 1st, P to the 15th. That's just going to be a P to the 1st. Now, when we look, and I realize, did I copy this? Oh, you know, I did the numerical part wrong. Do you see what I did? I thought I had copied it wrong, but I didn't. Can you find my error here? Find the GCF, common factor between those numbers. Okay, 4 is a factor of 16. 4 is a factor of 4. But is 4 a factor of 2? That's not a factor of 2, is it? So let's go back. Let's fix that. Did you catch that error before I did? 2 is a factor of 2. And since 2 is the largest thing that they all have in common, I should have put a 2 there. So the greatest common factor, excuse me, is 2x squared yp. And that's your greatest common factor for all 3 terms.